Hey friends, welcome back to the channel. Today we re-diving into one of the biggest questions humanity has ever asked. Are we the only intelligent species in the universe? I mean, think about it. Billions of stars, countless planets. Surely we're not alone, right? Or maybe we are. And if there are other intelligent beings out there, do they wonder the same thing? Are they sitting on their own version of Earth, looking up at their sky, asking, is anyone else out there? It's wild to think about. And here's the kicker. If aliens do exist, how do we even say hello? How do we bridge the gap between two totally different species across the vastness of space? That's where NASA comes in. They've been obsessed with this idea for decades, and one of their boldest moves was launching the Voyager missions. Back in 1977, they sent two spacecraft, Voyager 1 and Voyager 2, into space with a mission that's straight out of a sci-fi movie. Explore our solar system, head into the unknown beyond, and carry a message for any aliens who might find them. These aren't just machines, they're like humanity's ambassadors drifting through the cosmos with a little piece of us on board. So, in this video, we're going to unpack the whole story of the Voyagers, where they went, what they found, and what they're carrying for those hypothetical extraterrestrials. Buckle up because this is going to be a ride. Let's start with the basics. The Voyager program kicked off in 1977. But the idea was born years earlier. Picture this. It's 1965, and an engineer at NASA named Gary Flandreau is crunching some numbers. He notices something incredible. The outer planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, are about to line up in a way that only happens once every 175 years. It's like a cosmic jackpot. This alignment meant a spacecraft could swing by all four planets using their gravity to slingshot itself along, saving fuel and time. This trick is called gravity assist, and it's pure genius. Imagine throwing a ball past a moving car. It picks up speed from the car's motion. That's what these planets do for a spacecraft. So NASA jumps on this rare opportunity. They plan two missions, Voyager 1 and Voyager 2. Their goal? Explore the outer solar system, snap some killer photos, collect data, and then keep going, out into interstellar space, the vast emptiness between the stars. Our Milky Way galaxy has millions of solar systems, and the space between them? That's interstellar space. It's dark, it's mysterious, and it's where the Voyagers were headed. But here's the thing. Getting there takes forever. NASA has launched only 5 interstellar spacecraft in total. Pioneer 10, Pioneer 11, Voyager 1, Voyager 2, and New Horizons. And only the 2 Voyagers have actually made it to interstellar space so far. Why? Because space is huge, and these journeys take decades. Let's talk about how these spacecraft were built, because that's a story in itself. Both Voyagers are powered by something called radioisotope thermoelectric generators, or RTGs. No solar panels here. Why? Well, once you get past Mars or Jupiter, the sun's rays are too weak to power anything. So they used plutonium, a radioactive element. As it decays, it releases heat, and that heat gets turned into electricity. It's like a tiny nuclear battery keeping these probes alive. Each Voyager also carries 10 scientific instruments, cameras, spectrometers to measure stuff like hydrogen and ultraviolet light, magnetometers for magnetic fields, and a big high-gain antenna to phone home to Earth. These things were built to last, and they've been sending us data for over 40 years. Now here's a fun fact. Voyager 2 actually launched first, on August 20th, 1977, from NASA's Kennedy Space Center. Then 16 days later, on September 5th, Voyager 1 took off. But Voyager 1 had a shorter, faster route, so it ended up overtaking its sibling. Their paths were different too. Voyager 1 was set to fly by Jupiter and Saturn, with a special focus on Saturn's moon Titan. Voyager 2, it got the grand tour. Jupiter, Saturn, Uranus, and Neptune. No other spacecraft has ever visited Uranus or Neptune, so Voyager 2 is a legend for that alone. Let's follow their journey. First stop, Jupiter. Voyager 1 got there in March 1979, and oh man, the photos it sent back were mind-blowing. It took 66 images, each snapped after Jupiter's 10-hour rotation, and stitched them into this amazing time-lapse. For the first time, we saw Jupiter's swirling clouds up close, those red, orange, and white bands of gas. And get this, Voyager 1 discovered Jupiter has rings. Everyone thought Saturn was the only planet with rings, but nope, Jupiter's got them too. They're faint and dusty, not as flashy as Saturn's, but they're there. We call Jupiter, its rings and its moons, the Jovian system, after the Roman god Jupiter. Cool, right? But the real jaw-dropper was Jupiter's moon Io. Voyager 1 spotted active volcanoes spewing lava, actual volcanoes on another world. Before this, we didn't even know moons could be that geologically alive. And speaking of moons, we thought Jupiter had 13 back then. Voyager 1 found 2 more, bumping the count to 15. Then, in July 1979, Voyager 2 swooped in, got even closer, and found another one. That brought it to 16, but here's the crazy part. Today we know Jupiter has at least 95 moons. Some are tiny, some we're still confirming, but it's wild how much these missions opened our eyes. Next up, Saturn. Voyager 1 reached it on November 12, 1980, and it was another treasure trove. It found 3 new moons, Atlas, Prometheus, and Pandora. Yep, Pandora, like the planet in Avatar, but this one's real. Saturn had about 15 known moons back then. Now we've counted 146, with more being discovered. Voyager 1 also got up close with Titan, Saturn's biggest moon. This place is insane. It's got a thick atmosphere, thicker than Earth's, and there's evidence of liquid water and methane lakes. Sci-fi writers love Titan because it is one of the few places in our solar system where life might exist, or where humans could one day set up camp. By this point, the Voyagers had already changed how we see our solar system. They gave us stunning photos, new moons, and a front-row seat to the gas giants. But their story was just getting started. In Part 2, we'll follow Voyager 2 to Uranus and Neptune, then see how both probes left our solar system behind. Plus, we'll talk about that famous pale blue dot photo that puts everything into perspective. Stick around. There's so much more to come. Welcome back, friends. In Part 1, we followed Voyager 1 and 2 as they zipped through our solar system, snapping pics of Jupiter and Saturn and uncovering moons and rings we didn't even know existed. Now, in Part 2, we're picking up where we left off. Voyager 1's path diverged after Saturn, but Voyager 2? It kept going, hitting Uranus and Neptune, places no other spacecraft has ever visited. Then both probes set their sights on the ultimate goal, interstellar space. And along the way, Voyager 1 gave us one of the most iconic images ever. Let's dive in. So, after Saturn, Voyager 1's trajectory shifted. It used Saturn's gravity to slingshot upward out of the ecliptic plane, that is the imaginary flat disk where all our planets orbit the sun. Think of it like a dinner plate, with the sun in the middle and the planets spinning around it. Voyager 1 basically said, "See ya," and headed above that plane, toward the edge of our solar system. Meanwhile, Voyager 2 stuck to the ecliptic, cruising toward Uranus. It got there in January 1986, and wow, what a sight. Uranus is this pale blue-green ball of gas, tilted on its side like it's taking a nap. Voyager 2 sent back the first close-up shots, showing its faint rings and a handful of new moons. 10 of them, in fact. Then, in August 1989, Voyager 2 reached Neptune, the farthest planet from the sun. Neptune's this deep blue beauty with wild storms, like the Great Dark Spot, a hurricane bigger than Earth. Voyager 2 found more moons here too, including Triton, which has geysers shooting nitrogen into space. Crazy, right? It's the only spacecraft to ever visit these distant worlds, and those images are still the best we've got. By now, Voyager 2 had toured all 4 gas giants, Jupiter, Saturn, Uranus, and Neptune, making it the ultimate road trip champ. But the real mission was still ahead. Both Voyagers were built to leave our solar system and enter interstellar space. To understand that, we need to talk about the sun's influence. The sun pumps out something called solar wind, charged particles streaming outward, creating a bubble around our solar system called the heliosphere. It's like a shield, protecting us from cosmic rays and interstellar radiation. But that bubble has an edge. First, you hit the termination shock where the solar wind slows down. Then comes the heliopause, the outer boundary where the sun's influence fades and interstellar space begins. Voyager 1 hit this milestone first. On August 25, 2012, it crossed the heliopause and officially entered interstellar space, 24 years after its interstellar mission began in 1990. How did we know? Its plasma wave instrument picked up vibrations from a solar eruption in 2013, showing a spike in electron density way higher than inside the heliosphere. It was proof it had left the sun's bubble and entered the cosmic ocean beyond. NASA took 8 months to confirm it, announcing in September 2013 that a human-made object had finally escaped our solar system. Voyager 2 followed on November 5, 2018, giving us a second data point from interstellar space. Now, let's rewind a bit because before Voyager 1 left the heliosphere, It gave us something unforgettable. On February 14, 1990, Valentine's Day, it turned its camera back toward home from 6 billion kilometers away and snapped the pale blue dot photo. Earth in that image? A tiny speck, barely a pixel, floating in a beam of sunlight. Carl Sagan, the famous scientist who helped design the Voyager's alien messages, said it best. That's home, that's us, on it. Everyone you love, everyone you know, every human who ever was, lived out their lives. It's humbling, right? Venus, Jupiter, Saturn, Uranus, and Neptune show up in this family portrait too, but Mercury and Mars are lost in the sun's glare. And poor Pluto, well, it's not a planet anymore and too small to spot. After that photo, Voyager 1's cameras were shut off to save power. There wasn't much left to see, just the endless dark of space. But the probes kept going, powered by those plutonium RTGs, which are slowly fading. Today, Voyager 1's flying at over 61,000 kilometers per hour, about 17 kilometers per second, and it's nearly 25 billion kilometers from Earth as of October 2024. Voyager 2's not far behind. They're the farthest human-made objects ever, and they are still sending faint signals back through NASA's Deep Space Network. Huge radio dishes in California, Madrid, and Canberra, Australia. So what's out there in interstellar space? It's not totally empty. There's interstellar wind, particles from other stars, and it's a whole different environment from the heliosphere. The Voyagers are teaching us about it bit by bit. But here's the big question. Will they ever reach anyone? They were carrying messages for aliens. The golden record, which we'll unpack in part 3. That's where this gets really wild. What did we send? How would aliens even understand it? And what happens when the Voyager's power runs out? Stay tuned for the final part. Hey friends, we're back for part 3, the final chapter of our Voyager journey. In parts 1 and 2, we followed Voyager 1 and 2 as they explored our solar system, broke through to interstellar space, and gave us that stunning pale blue dot photo. Now, we're zooming in on the most incredible part of their mission, the golden record. This is humanity's mixtape for the universe. A message in a bottle drifting through space, hoping to tell aliens who we are. Let's break it down. What's on it, how it works, and what it means for our future. First, a quick history lesson. Before the Voyagers, NASA tried sending messages with Pioneer 10 and 11 in the early 70s. Those had small aluminum plaques with basic drawings, a man, a woman, a map of our solar system, and the sun's position relative to 14 pulsars, which are like cosmic lighthouses. It was simple, a "hey, we're here" kind of thing, but the Voyagers took it to the next level. They carried 12-inch gold-plated copper discs, phonograph records, packed with sounds, images, and a snapshot of Earth in 1977. There's one on each probe, so that's 2 chances for aliens to find them. What's on these golden records? 4 sections. First up, scenes from Earth. This has 115 images encoded as audio. Yep, audio, not digital files, because back then, tech wasn't what it is now. You've got basic math and science stuff. Circles, units, chemical elements like hydrogen and oxygen, even DNA diagrams showing how life works. Then there's pics of our solar system, Mercury, Mars, Earth, Jupiter, with details like Earth's atmosphere being 78% nitrogen, plus human stuff, people eating, the Taj Mahal, the Great Wall. It's all positive. No wars or disasters, just the best of us. Second section, greetings from Earth. This is 55 spoken greetings in different languages, everything from ancient Akkadian to modern English. There's also written messages from President Jimmy Carter and UN Secretary General Kurt Waldheim, saying things like, "We hope to join you in peace someday." Third, music from Earth. 28 tracks from Beethoven to Chuck Berry to an Indian raga called Jat Kahan Ho by Kesarbai Kirkar. It's a musical tour of humanity. And fourth, sounds of Earth. 21 clips, waves crashing, birds chirping, a baby crying, a tractor rumbling. It's Earth's soundscape. Here's the catch. Aliens need to figure out how to play this thing. The record's a phonograph like an old-school vinyl player. You put a needle in the grooves, it vibrates and sound comes out. NASA included instructions, diagrams showing how to set it up and play it at 1623 RPM. But honestly, look at these diagrams. Could you figure it out? I'd bet most of us would be stumped, so good luck to the aliens. And the images? They're trickier. Back in '77, you couldn't store JPEGs on a disk. So NASA filmed the photos on a screen, turned the video into audio waveforms, and etched that onto the record. To see them, aliens would need to reverse engineer it into visuals. The instructions are there, but it's like a cosmic IKEA manual, super technical. Will they get it? Who knows? First, the Voyagers have to reach someone. They're zooming through space. Voyager 1 at 61,198 kilometers per hour. Voyager 2 a bit slower, but space is vast. The nearest star system, Proxima Centauri, is 4.24 light-years away, and the Voyagers won't get there for tens of thousands of years. Even then, they might just drift past. And if an alien species finds them, they'd need the tech and smarts to decode it. Carl Sagan thought it was worth a shot. He said it's more about us showing we curious and hopeful than actually expecting a reply. What's next for the Voyagers? Their power's fading. Those RTGs are running out of juice, and scientists say by late 2025, maybe December, they might go silent. We'll lose contact, but the probes will keep drifting, golden records intact, for billions of years unless something smashes them. Imagine that. Long after Earth's gone, these little time capsules could still be out there carrying our story. So what do you think? Will aliens ever find the golden record? Will they understand it? And what does it say about us that we sent it? Hit the comments. I want to hear your thoughts. This has been an epic journey, friends. If you liked it, check out my Area 51 video next. Links on the screen. Thanks for watching, and I'll see you in the next one.